Section 6.2 Introduction to Proportions. In this video we will learn how to compare two ratios or rates, the definition of a proportion, the difference between the extremes and the means of a proportion, how to solve a proportion with the product of extremes and means, and applications involving solving proportions. In Section 6.1 we introduce the concepts of ratio and rate. In this section we equate these ratios in a construct called a proportion. A proportion is a statement that equals two ratios or rates. For example, each of the equations, 1/3 equal to 2/6, 15 miles over 2 hours equal to 30 miles over 4 hours, and A over B equals C over D compare two ratios or rates, and is a proportion. The proportion 1/3 equal to 2/6 is read 1:3 as 2:6. The four numbers that make up this proportion are called the terms of the proportion and are ordered in a natural manner. 1 is the first term, 3 is the second term, 2 is the third term, and 6 is the fourth term. Extremes and means. The first and fourth terms are called the extremes of the proportion. The second and third terms are called the means of the proportion. In the proportion A over B equals C over D, the terms A and D are the extremes, the terms B and C are the means. If we multiply both sides of the proportion by the common denominator, then cancel, we get the following result. A times D equals B times C. This leads to the following observation. The product of extremes and means. In the proportion A over B equals to C over D, the product of the means equals the product of the extremes, that is, the product of A and D equals the product of B and C. We can get an equivalent result using a technique called cross multiplication. The product of the means B and C equals the product of the extremes A and D. Example 1. Which of the following is a valid proportion? A, 2 over 3 equal to 7 over 12, or B, 4 over 9 equal to 12 over 27. Solution. Cross multiply. Looking at the first proportion, we have 2 times 12 is 24 equals 3 times 7 is 21. Hence, the product of the extremes does not equal the product of the means, so 2 over 3 equals 7 over 12 is not a valid proportion. B, cross multiply 4 over 9 equal to 12 over 27 to get 4 times 27 is 108, and 9 times 12 is 108. 108 equals 108, hence the product of the extremes equals the product of the means, so 4 over 9 equals 12 over 27 is a valid proportion. Solving proportions. We already have all the tools needed to solve proportions. Let's begin with the first example. Example 2. Solve the proportion for x in the equation 3 over 4 equal to x over 12. Solution. Cross multiply, then solve the resulting equation. We have the product of 4 and x equals the product of 3 and 12. On the left, the product of 4 and x is 4x, and on the right, the product of 3 and 12 is 36. To solve for x, we will divide both sides by 4. On the left, we have 4 times x divided by 4 equals x, and on the right, 36 divided by 4 is 9. To check it, substitute 9 for x in the original proportion and check. The original proportion was 3 over 4 equals x over 12, so substituting 9 for x, we get 3 over 4 equals 9 over 12. We'll cross multiply 3 times 12, which is 36, and 4 times 9, which is also 36. Thus, the solution 9 checks. Example 3. Solve the proportion for n. 3 over 2 equals 24 over n. Solution. Cross multiply, then solve the resulting equation. So if we cross multiply, on the left we get the product of 3 and n, and on the right the product of 2 and 24. So on the left we have 3n, and on the right we have 48. If we divide both sides by 3, we'll get n by itself. So on the left we have 3 times n divided by 3 equals n, and on the right 48 divided by 3 is 16. To check, substitute 16 for n into the original proportion and check. So when we substitute 16 for n, we get 3 over 2 equals 24 over 16. When we cross multiply, we have the product of 3 times 16 equals the product of 2 times 24, and both are 48. Therefore, the solution 16 checks. Example 4. Solve the proportion for x. 2x plus 1 over 15 equals 1 over 3. Solution. Cross multiply and solve the resulting equation. If we cross multiply, we have on the left the product of 3 and the sum of 2x and 1, and on the right the product of 15 and 1. So on the left we have to distribute the 3. We get 3 times 2x is 6x, and 3 times 1 is 3. So on the left we have 6x plus 3. On the right, 15 times 1 is just 15. We'll solve the equation 6x plus 3 equals 15 for x. First, we'll subtract 3 from both sides. So on the left we have 6x plus 3 minus 3 is 6x, and on the right we have 15 minus 3 is 12. We'll divide both sides by 6. So on the left we have 6 times x divided by 6 is x, and on the right 12 divided by 6 is 2. So x equals 2. We will leave it up to our readers to check the solution. Applications. A number of practical applications involve solving a proportion. Example 5. If 5 oranges cost $1.15, what will be the cost for 15 oranges, assuming an equal rate? Solution. Let x represent the cost for 15 oranges. Assuming the rate for 5 oranges at $1.15 equals the rate for 15 oranges at an unknown cost x, we set up the following proportion. 5 is to $1.15 as 15 is to x. We'll cross multiply So we get on the left the product of 5 and x, and on the right the product of 15 and $1.15, which is 17.25. We'll divide both sides by 5 to solve for x, so we have on the left 5 times x divided by 5 is x, and on the right 17.25 divided by 5 is 3.45. Thus 15 oranges cost $3.45. Checking units is extremely important. When setting up a proportion, check to make sure that both numerators have the same units and both denominators have the same units. For example, in example 5, both numerators have oranges as units, and both denominators have dollars as units. So 5 and 15 were the oranges, 1.15x were representing dollars. On the other hand, if we had set up the proportion incorrectly as follows, placing 5 oranges in the numerator of the first fraction and 15 oranges in the denominator of the second fraction and $1.15 in the denominator of the first fraction and x dollars in the numerator of the second fraction, a quick check of the units reveals the error, i.e. the numerators have different units and the denominators have different units. Checking units helps us avoid errors. Example 6. Dylan and David are planning a backpacking trip in Yosemite National Park. On their map, the legend indicates that 1.2 centimeters represents 2 miles. How long is their trip? The route measures 10.6 centimeters on the map. Round your answer to the nearest tenth of a mile. Solution. Let's set up a proportion with units. So 1.2 centimeters is to 2 miles as 10.6 centimeters is to x miles. Note how including the units aids in the setup of the proportion. Now let's drop the units and solve for x. We'll cross multiply to get on the left the product of 1.2 and x, and on the right the product of 2 and 10.6. The product of 1.2 and x is just 1.2x on the left, and the product of 2 and 10.6 on the right is just 21.2. Now we have the equation 1.2x equal to 21.2. We'll solve for x by dividing both sides by 1.2. So on the left we have 1.2 times x divided by 1.2 is x, and on the right 21.2 divided by 1.2 approximately equals 17.66. We carry the division on the right 1 decimal place past the tens place. The rounding digit is a 6, and the following test digit is a 6. Add 1 to the rounding digit and truncate. To the nearest tenth of a mile, the backpacking route is approximately 17.7 miles. Example 7. A recipe making 2 dozen cookies requires 1 3/4 cups of flour among other ingredients. If the baker wishes to make twice that number of cookies, how much flour is required? Solution. Twice 2 dozen is 4 dozen cookies. Let x represent the amount of flour needed for 4 dozen cookies. Assuming an equal rate for 2 dozen cookies, 2 dozen requires 1 3/4 cups of flour. We set up the following proportion. Again, using units helps us craft the correct proportion. 2 dozen is to 1 3/4 cups, as 4 dozen is to x cups. Note how including the units aids in the setup of the proportion. So we have dozens in the numerators and cups in the denominators. Now let's drop the units and solve for x. We will cross multiply, getting 2x on the left and 1 3/4 times 4 on the right. 1 3/4 is equivalent to the improper fraction 7 over 4, and 7 over 4 times 4 is 7. We have 2x equals 7. We'll divide both sides by 2 to get x by itself. On the left we have 2 times x divided by 2 is x, and on the right 7 divided by 2 is 7 over 2. Change the improper fraction to a mixed fraction, thus it will take 3 1/2 cups of flour to make 4 dozen cookies.